Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Problem 159. Using Mohr circle, determine the moments and product of inertia of the elliptical area with respect to the UV axis. Note that the axis passes through the centroid C of the area. So, although we should call this I bar U, but we'll just call this IU, IV, IX, IY, noting that this axis pass through the centroid. So, for the solution, we compute Ix, which is for the ellipse pi AB cube over 4. So pi AB cube over 4, I barred x or Ix, and it is equal to pi times 8, 4 cube over 4. In decimal, it is equal to 402.12 inches to the fourth. Likewise, I barred y or simply Iy is equal to pi A cube B over 4. So pi times 8 cube times 4 over 4. In decimal, it is equal to 1608.5 inches to the fourth. While the centroidal product of inertia, because an ellipse has two axes of symmetry, even if there's only one, it is 0. So remember the principle that for an area with at least one axis of symmetry, the product of inertia is 0 with respect to the centroid. So we plot 402.12 and 0, comma 1608.5, comma 0 because product of inertia is 0. So we imagine that its grid is 200 inches to the fourth. So 402.12 should be somewhere here. And 600, 800, 1002, 1004, 1608.5 will be there. And we then draw the circle. This is 402.12, while the distance from the product of inertia axis is 1608.5. Then we draw the circle, more circle. The location of the centroid is simply the average of these coordinates. 402.12 plus 1608.5 all over 2. That would be, so this is the centroidal x-axis. This is the first point plotted. This is the centroidal y-axis. They are 180 degrees apart. So the centroid, the center of the circle, is the average of 402.12 and 1608.5. So that would be 1005.31. So therefore, the radius is 1005.31 minus 402.12. That's the radius. Then from the x-axis, which is centroidal x-axis, which is here the principal axis, we rotate counterclockwise. So from the centroidal x-axis, that's counterclockwise to locate u. So from the x-axis, centroidal x-axis, counterclockwise 2 times 35, double the angle, the same sense, 35, so 70 degrees. That's the u-axis. The opposite side is the v-axis. Then the radius is denoted by r. As I said, it is 1005.31 minus 402.12. So this angle is 2 times 35 degrees or 70 degrees. That's also 70 degrees. This is the radius, that's the radius. So remember, that's also 70 degrees. So R is 1005.31 minus 402.12 or 1608.5 minus 1005.31. It's the same. So R is equal to 603.19 inches to the fourth. So having found R, then we indicate this as I sub u, I bar u or I sub u. Then this one is I sub v. And the product of inertia is this one. So it is below the principal axis, therefore it is negative. So that's 70 degrees. This is also 70 degrees. Imagine this we have a right triangle. This is equal to radius cosine 70. So I sub u, I bar u, is equal to 1005.31 minus this projection of this right triangle. Hypotenuse r cosine of 70. So I bar u is equal to 1005.31 minus r cosine of 70. And this is product of inertia P bar uv negative r sine of 70. So I bar u is 1005.31 minus r cosine of 70 degrees. So I bar u is equal to 799.0 inches to the fourth. Likewise, I bar v is equal to centroidal coordinates 1005.31 then plus r cosine 70. So this projection is r cosine 70. So I bar v is equal to 1005.31 plus 603.19 cosine 70 degrees, and that is equal to 212 inches to the fourth. Finally, product of inertia PUV, which is this, is negative r sine of 70 degrees. This height of this right triangle. So r, negative r, because it is below the principal axis, so negative product of inertia r sine 70. So PUV, P bar UV is negative 566.8 inches to the fourth. So that's it for this problem. So for example, 160 or level 160, given that the properties of the region shown are IX 3000 inches to the fourth, IY 2000 inches to the fourth, and product of inertia X sub Y, so still through the centroid. So there's no need to put P bar as long as we notice that, or we are aware that these axes pass through the centroid. So these are centroidal values, centroidal product of inertia, centroidal moment of inertia. So determine I sub u, I sub v, and PUV for theta equals 120 degrees. 120 degrees counterclockwise from the x-axis. So we plot IX 3000, comma, P bar XY or PXY negative 500. And the other pair would be 2000 and negative of negative 500, so positive 5000. And we have the axis here. We imagine that its grid is, graduation is equal to 250. So 250, so that's approximately 3000 inches to the fourth, and this is negative 500. Then the other partner, 2000, 1000, 250, 500, 750, 2000. So here 2000, then positive 500. Then this is the first point plotted. This is the x sub c axis. This is the y sub c axis, or centroidal axis. And that's the diameter. This is the x sub c, y sub c. From the centroidal x-axis, we rotate 2 times 120 degrees. That's 240 degrees counterclockwise. So from the x sub c axis to y sub c axis, that's 180. And since the location of the centroid is 3000 plus 2000 divided by 2, so 2500. That's 2500. That means this part, this leg of this right triangle is 3000 minus 2500, so 500. The opposite is also 500. Therefore, the radius is 500 square root of 2, or square root of 500 square plus 500 square. So that's 500 square root of 2. This angle is 45 degrees. There's no need to compute because the opposite legs of the right triangle are equal. So that's also R. So that means 240 degrees from the centroidal x-axis, that's 180 already, plus 45 to 25, then plus 15 to make it 240. So somewhere here would be the U, barred U axis. So that's 45. This is the angle 240 degrees counterclockwise. So R is 500 square root of 2. And this is the U-axis, centroidal U-axis. The opposite is the centroidal V-axis. So that's 45. That should be 15 to make it 180 plus 60, 240 degrees. So that's the u-axis. This is the v-axis, centroidal v-axis. This is I sub u, I bar u or I sub u. Then this is IV. And the product of inertia is this one, which is below the principal axis. Therefore, product of inertia P uv or P bar uv is still negative r sine of 15 degrees. Negative r sine of 15 degrees. The opposite side of this imaginary right triangle. So that's radius sine of 15 degrees. So that's also 15 degrees. So IU is centroidal moment of inertia, then minus r cosine 15. So the horizontal leg of the right triangle with angle 15 degrees is hypotenuse r cosine 15. Since we move to the left to locate the u-axis to compute for I bar u or I sub u, it is 2500 minus r. This is r cosine of 15. So I sub u is 2500 minus r 5500 square root of 2 cosine 15, 1817 inches to the fourth. Likewise, I sub v is centroidal value 2500, and this is plus r cosine 15. Because we have like identical triangles, we just move to the right, so we add r cosine 15. So IV is 2500 plus r cosine of 15 degrees, and I sub v is equal to 3183 inches to the fourth. Finally, PUV is negative r sine 15. So this value here, the opposite leg of this right triangle, but it is negative r sine 15. So PUV is negative 183.0 inches to the fourth. So that's it for this problem.